Hi there, this is Penelope. This is a short video on one of the assignment questions for DE 4102, but anybody else watching it, it's just a maximum voltage question where the function is given to you as that. Now, you can do this two ways. We can do it by calculus. So the first way would be by calculus. And the second way we can do using the formulas on the formula sheet that you've got. Okay, so let's find the derivative. So E dash is going to be 15 times 50 pi cos 50 pi t minus 50 pi times 40 sine 50 pi t, and that's got to equal 0 for max or min. Now, you've done a lot of these questions before, and you just have to remember you need to put one of the terms on one side and one on the other. So let's rearrange that so that we've got, and I'm doing the multiplication as well, 750 pi cos 50 pi t equals 2000 pi sine 50 pi t, and then we can rearrange that. Let's just do it a little bit of baby steps. And you should be able to see that the right hand side is equal to tan 50 pi t, and the left hand side, if we cancel the pi's and cancel the zeros and then divide by 25, that we will have 3/8. That means now to find t is going to be tan inverse, I'll do it all in one, 3/8 divided by 50 pi, and we will get 0.00228 seconds. It's something that might be better as milliseconds, but never mind. Now, to find the actual voltage, we need to substitute that back into our voltage function. And if we do that using the calculator, make sure you're in radians, we get 42.72 volts. But we're asked to maximize. I don't know that that's a maximum. It might be some crazy one and it might be a minimum, so we need to find the second derivative. And if we do the second derivative, it's negative 50 pi times 15 times 50 pi sine 50 pi t minus 50 pi times 40 times another 50 pi cos 50 pi t, and if you substitute in 0.002284, you get that the second derivative is negative, so that tells us that we have a maximum of 42.72. Use the units volts. Now, you weren't asked for it, but when t equals 0.002284 seconds. Now, I said you could do this another way. You could remember that you are given the formula for the amplitude as being r equals the square root of a squared plus b squared, or x squared plus y squared, and from here a equals 15, and remember b is the one that's next to the cos, and b equals 40, so therefore r equals the square root of 15 squared plus 40 squared, which is, surprise, surprise, 42.75. Now, that is, to me, much quicker than doing it by calculus, provided you're not asked to find the time that occurs. right, if you are asked to find the time, then you could go ahead. So that's the end of the question. But if you need to find the time, so now we've got that E equals 42.75 sine, and this is topic 6, part 3. Sine 50 pi t plus alpha. You're given the formula for alpha. Alpha equals tan inverse of b over a, which is tan inverse 40 over 15. Okay, using calculator, making sure your calculator's in radians, we get that alpha equals 1.212 roughly. So now we've rewritten that original function as E equals 42.75 sine 50 pi t plus 1.212. Now, we're trying to find where that is maximized. That means that it'll be maximized when 42.75 equals 42.75 sine 50 pi t plus 1.212. Okay, bring that over to that side and divide, and then we've got that 1 equals sine 50 pi t plus 1.212. I'm going to do this all in one big, maybe I'll put in a step. So sine inverse of 1 equals 50 pi t plus 1.212. Okay, in one go. Therefore, t is equal to pi by 2 minus 1.212 divided by 50 pi. Do the number crunching, and surprise, surprise, t is equal to what we had before. So your choice in the exam, if the question only asks you for the maximum, I'd be doing it this way. If it asks you for the maximum and when, then both ways take up about a page. Okay, thanks for watching.